Welcome back, everyone. Welcome to Weather for Air Crews. Today, the topic of discussion is going to be turbulence. What we feel, what we see, how can we identify where it is, any of those types of things. And we're also specifically going to cover what do we do when we get into it and how do we get out of it? How do we keep ourselves safe and alive when we're flying in an area of turbulence? To start off, to define turbulence, basically anything irregular or disturbed atmospheric airflow that's producing the winds to change direction and or speed and cause it to go in a different direction, okay, and specifically in a short area in the atmosphere. That's what's going to cause the bumps of up and down, left and right, okay, turbulence that we're going to feel in the airplane. Sometimes it can be pretty drastic, sometimes it's not so bad at all. Okay, and we're going to classify the intensities of it as to how strong we feel. The lowest of those is going to be light, second would be moderate, the next would be severe, and the most difficult to counteract would be what we call extreme turbulence. So, and we're going to go into each one of those with a definition of each so that we understand when we hear someone report it, what are we actually going to feel, and when we feel it, what are we actually going to need to report? So for light turbulence, kind of the definition there, momentary, slightly erratic changes to the attitude, the altitude, so pitch, roll, and yaw, different things that are going to, the turbulence itself is going to make those things move and change. Okay, somewhat there, and while we're feeling this turbulence, we are going to feel a slight strain against the lap belt, okay, the shoulder straps, whatever's holding us tightly into the airplane. We're going to feel a slight strain against that as the airplane bumps around a little bit. And anything that we don't have in the cockpit that's not strapped down or not secured is going to be displaced, moved somewhere in the cockpit slightly. And realistically, we should never have an unsecured object in the cockpit of an airplane, ever. Okay, light turbulence really doesn't affect us as pilots much at all. Moderate turbulence, now the definition here, larger changes in altitude and attitude. Well, larger than what? Larger than momentarily slightly erratic. Okay, so best definition I can give you, okay, there without going into a lot more specifics. Okay, but we will start to see variations in the indicated airspeed. So as it's bumping around, we're going to see the airspeed change a little bit, maybe even wavering of the airspeed indicator. We're definitely going to feel a strain against the lap belt and shoulder straps, okay, that it's going to bounce us one side or the other. Okay, and anything that we have in the cockpit unsecured could be dislodged and, okay, drop down to the floor, okay, go get stuck in somewhere else in the cockpit that we really don't want it. So again, no unsecured objects in the cockpit at all. And in this little video going here, you can kind of see how moderate turbulence is going to bounce the airplane around a little bit. But most of the time for us pilots, it's a big deal. And passengers, though, they're not going to enjoy the moderate turbulence. They're not used to it at all. Okay, we go up to severe turbulence. Now we change that definition to large, abrupt changes in altitude and attitude. Key word there, abrupt. Things are definitely going to happen a little bit quicker. Large variations in indicated airspeed, potentially up to even 20-25 knots of airspeed change, just because of encountering whatever downdraft pushes us down in altitude and makes the airspeed increase, or an updraft that's going to actually slow us down to that much. Unsecured objects tossed from one side of the cockpit to the other, over it goes where you never know where it's going to end up. Okay, again, not something you want to have happen. Momentarily, the aircraft could be out of control. I know that sounds scary, but momentarily, and based on that, what we really mean is the turbulence rolls the airplane to the right. We throw that stick over to the left, but it continues to roll right for a moment or so, and then the controls become more effective than the turbulence. Okay, and here we can see it bouncing around a bit more, a little more abrupt kind of changes as to what we're going to see and feel. No one really enjoys flying through severe turbulence. Okay, the worst turbulence we can encounter here we're going to call extreme turbulence. Here the aircraft is violently tossed around. Pitch ups, rolls left, rolls right, pitch down. Okay, different things that are very difficult, sometimes impossible to control. Yeah, that does sound scary, and it is not fun to necessarily fly in. Possible structural damage. We could potentially see bending of the wings, breaking of things off of the airplane. And this is an area that we need to get out of in a hurry. And here, structural damage to the airplane. We do not want the wing off light to illuminate. It's time to get out of there if we start to encounter anything that heavy. When we report the turbulence, we're going to report that intensity, and we're also going to report the duration of the turbulence. How often is it happening? Okay, and the duration, we're going to break that into thirds. Occasional is less than 1/3, intermittent 1/3 to 2/3, and continuous more than 2/3 of the time. OIC, the duration of turbulence. Easy way to try and remember that. OIC, the duration of turbulence, broken down into thirds. And then we're going to classify the turbulence as to what causes it. Okay, and 4 different ways of different things that cause it. Thermal, the heating of the surface of the earth and causing that turbulence in the air to rise. Mechanical turbulence is going to be something that's in the way of the smooth wind blowing through there. Frontal, being a cold front as it's moving through, is going to cause a lifting action and cause turbulence. And then wind shears. Okay, different things are going to cause wind shears, like the jet stream or our land breezes and sea breezes and things like that. Anything causing gusty winds and a change in the wind speed or direction. Okay, and to go into each one of those for a little bit here, into a little bit more specifics with it. Thermal turbulence we also call convective turbulence. The sun heats up the earth, and it heats up the different types of surface of the earth differently. So a plowed field, we're going to get a much stronger updraft than we are over a lake or a very heavily wooded area. Okay, so it's the vertical air that's moving up, heating from below, and causing turbulence as we're flying across because we're moving into different areas. Sometimes it could be just some cold air moving over, not necessarily associated with the front. We're going to get some of that thermal lifting also. Okay, so the type of surface is what controls or has an impact on how severe the turbulence is going to be. Mechanical turbulence caused by the wind going around big buildings or mountains. Okay, something sticking up in the wind there. We kind of call Chicago the Windy City because we've got smooth air, winds blowing off of the lake, coming into the big buildings in the city. It has to go around it. It's going to be quite turbulent and increasing the wind speed there. Okay, anytime you're flying around and low altitude around the mountains, okay, they're doing the same thing. The winds are trying to go around it, changing the speed and direction around those things, and we're going to have turbulence associated with that. Okay, so think mechanical turbulence with buildings or any irregular terrain or mountains. What's going to make this mechanical turbulence stronger? Well, it's going to depend on how strong is the wind, what speed is the wind blowing, how rough or difficult is the terrain, and what's the stability of the air. So especially unstable atmosphere is going to cause more turbulence. With a front, okay, we're going to have to think a cold front here, as the cold front is lifting that warm air up in front of it, okay, and we're going to see potentially turbulence there out ahead of that cold front. Not necessarily a warm front because there's not going to be any major lifting going on with that. And the faster the front is moving, the more severe the turbulence could be. Okay, wind shears. Definition of a wind shear is any sudden change in the wind speed or direction over a short distance in the atmosphere, either vertically or horizontally. Doesn't matter which way whether we're climbing into it, whether we're trying to fly through it, or across it, there's going to be some turbulence associated with it. This slide up here kind of shows maybe we have a mountain breeze coming down to the valley that's going to change the speed of the wind as we're on final approach to a runway. Definitely going to have what we can call wind shear at that point. Okay, generally it's going to be in clear air, so we're also going to call it clear air turbulence. Okay, and the greater this change in the wind speed or direction, we're going to see that there. We're going to also see wind shears pretty much in the jet stream, Okay, anytime we have anything out there with gusty winds, and a temperature inversion can also cause a wind shear. Okay, as the temperature inversion, the cold air, the warm air are trying to mix together, we may get a small area of turbulence associated with that. Okay, and our land breezes, sea breezes, those types of things are going to change the direction of the wind over a short distance, and so we're going to see wind shears with air. And again, this could be called clear air turbulence also. Okay, what we call clear air turbulence, where are we going to see it and why? Not associated with any clouds or convective activity meaning thunderstorms. Okay, we're going to see or feel some turbulence, not necessarily see that it's there until we're in it, because there's no clouds to tell us. Usually we're going to find that in the jet stream, where we're going to see most of it or the most severe of it, but any of the four types of turbulence could be considered clear air turbulences if there's no clouds associated with it. Okay, so in the jet stream, okay, we've got a rapid change of the wind speed over a short distance from the core of it. Okay, like you can see, the red areas on this chart are going to be the higher speeds, and then slowing down as we get a little bit away from it. Okay, that rapid change in the wind speed there is going to cause turbulence, so we might want to get into that core, go in the right direction, and we're going to have some turbulence as we're getting to it and as we're in it. Okay, now with the jet stream, the vertical shear is a little bit more significant than horizontal, so climbing into it, you might feel it a little bit more than you would if you're flying across it at that altitude. Okay, generally in the U.S., and this is just a general statement here, if the turbulence with it gets too much, most of the time the jet streams over the northern parts of the U.S., so turning south, can kind of get us out of it. With a wind shear, we've got potentially warm air and cold air close in a small boundary between that, and we might get a turbulence that forms right around that wind shear boundary because of the two air masses trying to mix together. Okay, strong winds on one side, calm winds on the other. We're going to definitely see a boundary layer develop in between them, and as they're trying to mix together, as this little video is showing, there's going to be a small turbulent area right around where that shear zone actually is. But that shear zone itself can be even more difficult. Okay, as with what this is going to try and show you, here's a sudden change in the wind speed, okay, with strong winds up above that shear zone, very light winds down below that. And as we're trying to fly and approach to a runway and go through this shear zone, where we go from strong headwinds to light headwinds, that's going to cause a drop in our indicated airspeed. And we're going to need to be able to counteract that, otherwise we're not going to end up making it to that runway. We've got to be able to potentially carry more airspeed, okay, as long as we know it's there, or we got to expect it once we see that. Okay, the closer it is to the ground, the less time we have to react to it. So what this is going to show you as I put this into motion is going to be, as the airplane goes through the shear zone, you're going to see a drop in the indicated airspeed. Well, that's also going to equal a drop in lift. And if we don't compensate for it, we've got to be able to counteract that so that we get to that runway. And really the best thing is going to be just go around. There, we're dropping down, we've got to counteract that, and if we don't do it in a timely manner, we're not going to reach the runway. Now we can also flip this around and have a lighter wind up above and a stronger wind down below. And that, as we're coming on approach to runway here, that could be what we would call a performance increasing wind shear. To whereas we're trying to fly this glide slope, this yellow line on the screen there, down to the runway, and we get that performance increasing shear. Now our airspeed's going to increase, our lift is going to increase, and we're going to end up going further down the runway. And again, if we don't compensate for it correctly, we could end up landing long, going off the end of the runway, or we try and overcompensate for it, we pull the power too much, now we have too much of a descent to the runway there. And this type of wind shear can also happen very much in clear air. We don't know we're in it until it actually happens. So we got to compensate for this by increasing the airspeed, okay, because it's going to cause a higher descent rate for us. We could also flip this around, and we're not approaching the runway and landing, but we're taking off. So as we're taking off and we go through this shear zone and it becomes a performance increasing, hopefully we've got our landing gear and flaps up already before we go through that zone, and we see that rapid increase in the indicated airspeed. Okay, could be performance decreasing, okay, as we're climbing through that, and all of a sudden we don't get near as much lift as we were getting ahead before that, and we can see a pardon me, decrease in the performance and decrease in the climb performance of the airplane. One of the mechanical turbulences out there, what we call mountain wave. This can be very, very severe. There have been many airplane accidents associated with mountain wave turbulence. Okay, a strong wind blowing across the mountain. Okay, that fits the definition of the mechanical turbulence. Okay, and the wind blowing across here has to go around it. There's going to be a main downdraft that may reach the ground and may even be strong enough to not allow the airplane to climb over that mountain. So an area of mountain wave turbulence that you definitely want to avoid is going to be the strong downdraft on the downwind or leeward side of the mountain. Further downwind, it's going to form standing waves that go further and further and further away from the mountain that is causing this. And the turbulence that's going to be associated with it, we're going to be able to identify by the clouds that are going to be produced by this, but the turbulence is going to be in the clear air also, not only in the clouds. The clouds that we're going to see when we look out there and see that mountain wave turbulence is present there, number one is going to be the rotor clouds. And these are going to be about the height of the mountain peak, maybe even below that, but definitely on the downwind side of the mountain range. And they're going to look potentially like a cigar and sit there and just be rotating over, around and around and around, pretty much stationary in the atmosphere. Okay, and so an area of potentially extreme turbulence. And even from the rotor clouds, the downdrafts out of those things could potentially even go all the way and reach the ground. It may not necessarily be fully formed and fully cylindrical at that point. Okay, and here's an example of a forming rotor cloud. Okay, one on the left side of the screen, hey, just starting to see, and if we were actually had this in a video, we'd probably see that whole thing rotating by itself. And the picture on the right, a string of them, okay, that are forming a circle, continuing to form circle upon circle upon circle. Definitely an indication of severe to extreme turbulence. The next cloud that's going to form is what the meteorologists call a cap cloud. It's going to cover the mountain and it's going to be stationary. It's not going to move, and it's only there because of the pressure changes in the atmosphere, and then that's going to have the air or water molecules in the air condense right along the top of this mountain. So cap cloud is actually the meteorologist term for it. Us pilots like to call it a cumulogranite cloud, because in the middle of that cloud it is granite. It is solid rock. It's definitely a cloud that if we fly into, we're probably not going to come out the other side. And that cap cloud is going to cover the mountain peak, and we're not necessarily going to be able to see how and where the peak actually goes to. So here's an example, or two examples of what cap clouds look like. You can see they're actually covering the top of the mountain, okay, obscuring it completely from our view, and in neither one of those pictures can we actually tell where the top of that mountain is. So that cloud is one you definitely want to avoid. Okay, the third cloud that mountain wave is going to produce is what's called lenticular clouds. And these are going to be above the peak and above the rotor clouds, and potentially even further on downwind. Okay, so the leeward side or downwind side of the mountain, and stretching from the mountain peak and above, going higher and higher, and potentially further and further down away from the peak. Okay, examples of what lenticular clouds look like. In this first picture that's coming up here, it looks like they're all straight up above that cap cloud. Well, I believe this picture we're looking directly downwind at it, and so those clouds are actually further and further away from us. And the picture on the right side of the screen kind of shows how they slope a little bit away from where the mountain peak actually is. Okay, so lenticular clouds, again, an area that you want to avoid. Okay, and a rule of thumb, what can we expect when we see these clouds and we know that this mountain wave turbulence is present? Okay, how intense is the turbulence going to be? Well, if we have 50 knots of wind at altitude of the peak, you can expect extreme turbulence right there at the peak or very close to it. And remember that definition, potentially structural damage to the airplane. So we definitely want to avoid that area. Okay, and we could, even from that up to 150 miles away, still have severe turbulence. Okay, at the altitudes of the peak, slightly above, maybe even slightly below. Okay, and up to 300 miles away, still encounter moderate turbulence. So those of you that are here at Vance Air Force Base, there could be mountain wave turbulence up in Colorado Springs over Pikes Peak, and we could still have moderate turbulence here based upon that mountain wave turbulence happening there. So how do we avoid it? Number one, go around it. That's always going to be your best bet. Go around it, avoid those areas where the clouds are, avoid that mountain range, just go either left or right around the thing and we shouldn't have any problems with it. Okay, but if we can't do that for whatever reason, can I go over top of it? Well, if that's the case, I want to go 50% higher than what the peak is. So if the peak's at 12,000 feet, I want to be at least 18,000 feet going over top of all of that. And then I'll probably miss most of the severe to extreme turbulence. Definitely want to avoid the clouds that are formed from it. So avoid the cap cloud, the rotor cloud, the lenticular clouds. And if I got to go into this thing, if I approach it with a 45-degree angle, now I only got 90 degrees of turn to make to get away from it, instead of needing to do a total 180-degree turn. So it'll actually make it a little bit easier for us if we can see it out ahead of us and we come at it at the right angles. Okay, avoiding the cap cloud, and realize that not just mountain wave turbulence, okay, but any turbulence that we get into is going to cause pressure changes to the pitot-static system. So it's good, the pressure changes there are going to cause variations in our indicated airspeed. So we might not necessarily have a really good indication as to how well we are flying. How close are we to our actual stall speed? Okay, if we're at cruising altitudes and things like that, usually that's not going to be a big deal. But if we're encountering this, okay, somewhere close to slowing down to approach speed, now these pressure changes and changes in the indicated airspeed could be a problem because it could put us at a stall speed, okay, without us really knowing it. So when we're encountering turbulence, we want to fly what we call the recommended turbulent air penetration speed. Every airplane has this already designed for it. Okay, and for the T6, we're talking 180 knots, maximum of 195 knots, which keeps us below that cornering velocity or maneuvering speed. And if you remember back to the aerodynamics class, that's the speed at which we can actually bend the airplane. We can over-G the airplane symmetrically, okay, and cause damage to it. Well, if we're below that speed, the turbulence isn't going to cause that potential structural damage. Okay, so in turbulence, get the airspeed where you want it, set the power, and leave it alone. We're going to try and hold that. We know we're going to have airspeed changes, but we're not going to chase them with the power control lever. We're just going to kind of keep that power set, and we're going to ride those airspeed changes out. We want to trim the airplane for level flight. We're going to have updrafts and downdrafts. The altitude's going to be changing on us, okay, and we're going to want to make smooth control application in there to get back to the desired altitude, but we don't want to be abrupt with it, because if we're abrupt with the control inputs, we're going to end up causing more turbulent effects, okay, as we go from a downdraft that pushes us down and we make an abrupt pitch up. Now we had an updraft and we've just doubled that turbulent effect. So we're not going to chase the airspeed deviations with the power, and we're not going to make abrupt pitch changes. Okay, we're going to allow the altitude to vary. Okay, again, we're going to slowly correct back to altitude. We're not going to make that. If you're in an airplane that has an autopilot, we're going to want to turn it off, because the autopilot's going to make those abrupt pitch changes to correct back to altitude and make the effects of the turbulence even worse. Okay, and if the turbulence happens to be in the clouds, the only reference we're going to have as to what's upright is with the attitude indicator. So we're going to need to make sure that we're following that, bringing ourselves back to wings level flight. Okay, that's all dealing with turbulence. Key things to remember: you're going to need to know the intensities and the duration of reporting it. So when you encounter it, what do you need to report? And when you hear or see a turbulent report, you know what you're reading and understanding. Okay, know what causes the turbulence. Okay, we're classified by what causes it. Is it thermal? Is it mechanical? Okay, those types of things. And is it considered a wind shear? Okay, know the definitions of each of those. Know what clouds are going to indicate turbulence to us. A cold front is going to produce cumulus clouds, so we know there's going to be turbulence around those. And the rotor clouds, the cap cloud, the lenticular clouds are going to indicate to us that mountain wave turbulence is present. Okay, clear air turbulence is no clouds. So we're not necessarily going to have any indication that we're getting into it, okay, with the clear air, any clear air turbulence. Again, the jet stream, okay, or different wind shears. Okay, note that wind shears can be very dangerous because it could cause us to, no kidding, lose airspeed, lose lift, and maybe not have enough room to overcome that. Okay, remember the techniques to avoid mountain wave turbulence. Go around it is going to be your best bet. Okay, always try and avoid things if you know they're there. Avoid those dangerous situations. Okay, and know the turbulent penetration airspeed. Okay, and what you want to do if you find yourself in turbulent air. Okay, how to safely get out of it, and then we won't do damage to the airplane. Okay, and that's all for turbulence. Our next module is going to be talking about icing. Turning an airplane into a popsicle is not necessarily a good thing. Okay, and we're going to talk about what the different types of icing are and how we're going to avoid that, similar to the way that we've done this with turbulence. Thanks again for watching, and I'll see you next time.